Hello everyone, my name is Fayaz Khan Sahil and today we're gonna learn about isotopes. So let's look at the definition. Isotope are the atom of the same element that have the same number of proton, however they have a different number of neutron. Let's look at an example. For example, aluminium 26 and aluminium 27. Aluminium 26 has a proton number of 13, neutron number of 13. However, when you look at the aluminium 27, it has a neutron number of 14, right? So it increases the mass number. How come it increases the mass number? Let's calculate it. Mass number is proton plus neutron, as electron has negligible mass, right? Let's look at this. Proton number 13, neutron number 13, total 26. That's why it's called aluminium 26. Now we have aluminium 27, which has 13 plus 14, which is 27, right? They have a different mass number. Moving on, let's look at another famous example. If you study STEM, you will get carbon 12 and carbon 14 a lot. Let's look at this example. As you can see in the screen, it has 6 proton, 6 neutron, which give it a mass number of 12. However, let's look at carbon 14, which has 6 proton and 8 neutron, right? So it has a mass number of 14. Let's question ourselves. You guys should have thought, right? Who discovered isotope? The concept of isotope was actually appointed by Frederick Soddy. However, the first isotope that was actually discovered was neon. It was discovered by Thomson. Let's look at the physical and chemical properties of isotope. The chemical property of isotope of a given element, they are almost the same or identical. Why is that? Have you ever thought about it? Just giving it a definition. Look, isotope, a neutron number increases, right? Neutron number has no role in chemical reactions, right? The chemical reactions are occur because of the electron number in its outer shell, right? In isotope, the proton number and electron number remain the same, so the reactivity of the element is same. So that is why it has the same chemical properties. However, things get interesting. When it comes to mass number, it actually play a key role. For example, it has a greater mass number. If mass number is greater, you will see it has a higher melting point, right? And also its mass increases, right? Neutron has a mass, and also its melting, both its melting and boiling point increases, as well as density, freezing point. They are all different for different isotopes. Now let's look at type of isotopes. We have radioactive isotope, we have stable isotope. Let's look at the radioactive isotope. Radioactive isotope are also known as radioisotope or radionuclides. So these will probably not come in your exam like for MCQs and other stuff, but it's better to know it, right? If you want to be a doctor, scientist, engineer, chemist, anything you pursue with science, you may know this thing, right? You have to know this thing. This is radioisotope, and this is also known as radioisotope and radionuclides. They are unstable and decay over time. Look, as these nucleus are unstable, they decay by producing, as you all know, alpha, beta, and gamma radiation. This is how the radioisotope actually decay, because of its having an unstable nucleus. However, some isotope have stable nucleus. They doesn't undergo radioactive decay and remain unchanged over time. Moving on to how many isotopes are naturally occurring. That thing, I was very into it. I asked my teacher how many isotopes are there, and I think he wasn't in the right mood. He didn't answer me, and he just shouted me like, "Study what is given to your slides." That was about 5 years ago. So no, actually 6 years ago. So let's look at, we have 339 naturally occurring isotopes, and among them, this is interesting. Among them, 286 are primordial. That's mean they have existed since the formation of solar system. We humans weren't alive when these 286 were, when it is produced. So this is very interesting for me. Let's interpreting atomic and ionic symbol. Look, this is a carbon atom, right? This is carbon atom. It doesn't have any charge, right, on it for these examples, right? It doesn't have any charge. So we have, suppose this is an atom, not suppose, this is atomic number. So atomic number is equals to 6. As we all know, atomic number and electron number are same. So it has 6 electron 2. Now let's look at an ion. This is an example of a chlorine ion. Chlorine, this is a chlorine ion, right? Chlorine has 17 proton, right? However, it has 18 electron, chlorine ion, right? Why? Because in outer shell of chlorine we have 7 electron. To get it a stable formation, it actually gain electron. That's why it has one extra electron. That is why it has a minus sign. Minus mean a ion that has gained electron, and plus means, for example, Na plus mean it has lost a electron. So this was one of the examples. Now let's look at how would you calculate atomic mass of an element from the relative masses and abundance of its isotope. For example, this is two examples, chlorine 35 and chlorine 37. As you can see, their mass number is given, relative mass is given, their abundance is also given. So it should be, let's take it M1, M2. Abundance, let's take it A1, A2. So the simple formula is total relative atomic mass is M1 into A1, okay, plus, let's move it a little bit upward, plus M2 into A2 divided by 100. For this example, we have put in the mass number over here into, for example, let me show you guys, okay. What was M1? M1 was 34.9969 into, what was the abundance? 75.80 plus, we have 30, for M2 it is 36.966 into 24.20 divided by 100. You will get an answer of 35.45. That's all of it for today. Please do subscribe to my channel to learn more about O-level and A-level chemistry and biology. See you guys next time.